In this video, we're going to look at creating a file system, and file systems are rather complex, so we probably won't get to everything, and most of this is going to be very simplified, but let's take a look at it and get started at least. So kind of the plan is we're going to use a super block. We need to implement a super block first to talk about the overall configuration. And then we'll talk about inodes for the files, and then the disk blocks for the files within the file system, and then how we, if we have time, how we would address accessing a file within this file system that we've created. So to get started, we're going to, part of our .h is we're going to want to have a struct that's the super block. And so what goes into the super block? Well, this is the meta information about the file system. So at a minimum, we might want to know like how many inodes and the, say, number of disk blocks. And let's also say the size of the disk blocks. And so we have these three ints right now. We could also do the size of the inodes, but we're going to have a very simplified version, so it might not be necessary. Okay, so our super block, and as you mentioned, we're also going to have inodes, and for now let's just say size, and name, and we're also going to need a disk block, and we're going to use kind of a file allocation table approach. And we'll have the next block number, and then a bunch of space or data. And let's make this just 512 bytes. Okay, so that's we're going to modify this as we go. We're going to think about what operations we want on this, and one operation would be to create the file system. And again, we're just going to do a very simple setup, and so we're not going to we're going to use global variables. So we want to be able to create and mount, and let's say sync. So a couple of comments. Okay. So let's get started with that, and let's so let's open up a .c file, and just for reference, I'll put that there. Now in the C file, I'm going to keep my global variables, and so I'm going to want to declare those. Mainly I'm going to declare the super block. I'll declare an inode. The inode and the disk blocks I can work with internally. Okay. So to implement the create function, and let's set these up quickly. So we're going to put this in a file on our regular file system. Okay. So I'm going to want to save these things. For now, I want, like when I create the file system, I'm just going to initialize my superblock data structure, and just arbitrarily I'm going to say something like num inodes, let's say, is equal to 10, and this is just random, and let's say this is 100. Now for the size of the blocks, let's use the size of operation. Okay, and so that's pretty much all that we're doing on this. Now the question is, how are we going to represent the rest of these things? So let's create an array of what's currently open. Okay, so we'll create two arrays like this, and then what we're going to do is we're going to initialize these. And we should allocate that space first. So it's C++ style. So let's do malloc. And one thing we're going to do in this video is use man pages a bit, right? So if I'm blanking a bit on the order parameters for malloc, I'm going to go and use the man page for malloc. And I'm going to see I just need to pass it the size parameter, and then that will allocate that. Okay, and I'm going to need to include standard lib. So I just need the size of, right? Oops. I guess that one doesn't have a man page. Okay. And again, because we're trying to be quick and not careful, I'm not going to check if that succeeds. So I've allocated that space, and I want to initialize it. And so I'm going to say inodes, right? And the data here is the size and a name. And I'm going to say -1 if it's not allocated. All right, so size and name. And now I need to do the same thing for the disk blocks. So I'm going to allocate them in memory. And then I'm going to go through and initialize them. And I'm not going to bother to initialize the data because it doesn't matter. Okay, so this has initialized the file system, right? We've set up our super block, and then we set up our inodes, and then we set up our disk blocks. How can we test this, right? Well, we can't do too much right now, right? So what we need to do is do a sync. We need to be able to write it. So we're going to use the fopen and fwrite. So we're going to open a file. So we're going to use standard.io.h. We're going to give it a path name and a character code. The character code is we're going to open for reading and writing. Okay. So let's fix our includes. and this takes a, this is going to return a files pointer. So let's allocate the file pointer. I don't think we need to make that a global. And I'm just going to call it a file system disk or data. And I'm going to open it for write plus. And then later on I'm going to need to do a close. So I think it's a good habit just to, when you do open, to also do the close, right? Just so that you're in the habit of doing that. So we're going to do the close when we're done. And then we're going to want to write data. So fwrite. And we're going to pass in the file pointer how much data we're writing, how many blocks. Oops, I'm sorry. So the first one here is the pointer of the data we're writing, how big that data is, how many items we're writing, and then the file. So first we need to write out the super block. So we do the super block and then the size of the super block. We're just doing one of them and in the file. Okay. Now the inodes, and we're just going to iterate through. So we got 2 loops we're going to be doing. And here we're going to do a fwrite. And inodes. And let's try this. And then our disk blocks. Okay. So let's see what errors I've made in there. So let's create a test file. So let's try creating the file system and then syncing the file system. And okay, so let's work on our makefile. So this is going to depend on okay. Oops. Okay. So lots of things. So let's start up. Oops. So I made a typo up here, and hopefully that was a bunch of it. Okay. Next one is line 37. Okay. So it doesn't. Okay. So what we'd want to do here is actually probably string copy. Right. So let's try that. So we're going to need to include string.h. And we pass it in the destination and the source. Okay. And then I forgot to change my data structure. And okay, so I'm going to need to pass it the address here. And then probably the address for these also. I could also multiply and add. Okay. So right now I don't have the data file there. So if this works, I should have a new file. Right. And here it is. And it's not very useful, right? I can't really see very much in there. Let's so the size though is 51,000 bytes ish, right? And that makes sense because we have 100 blocks and each block is about 512 in size. Let's put something more interesting in there. So the I set 8 characters for my name. So 1, 2, 3, 4, 5, 6, 7, and then a null to terminate. Don't forget the null in terms of counting for space. And so now if I run it, I should see those. Oh, I didn't make it though. So if you don't compile your code, it won't make changes. And here are my inodes, right? We could look at this with a hex editor too, but I suspect you don't have the patience to kind of deconstruct the data like that. So basically our super block is up here, and then our inodes, and then our data blocks are starting. So we have the first part looks okay so far. Next, what we're going to want to do is to be able to mount the file system. And mounting, basically we want to open it up and access it for use. And so when we do a mount, we're going to be opening it and copying data into our into it. In some ways, well, it's just the opposite of the write, the sync. So you can think of sync as doing a write, the mount as doing a read. I'm only going to be reading it, so I'm just going to open it as a read. And if I look at fread, I'm going to give it the destination pointer where I'm copying stuff to, how big, how many, and then the file. Okay, so essentially the same as the write. So I'm going to read in the super block, and then read in the inodes, and then read in the disk blocks. Now I don't know, how do I know that this is working? So let's add another function. This would be more interesting if we had if we took more time to have separate things, right? To open up multiple ones so we could see different data, but okay, our super. So let's just look at this and copy So we're going to want to print out the number of inodes. And the blocks, number of blocks, and the block size. And then let's print out the inode information. And then let's print out, well, right now I don't want to print out the data in the blocks. So let's just print out the chains. Oh, so something we need to fix is we don't hook the inodes to the first disk block. So we need to fix that. Okay. Okay. So let's fix our data structure. And then we need to fix our initialization. And it's set to -1 to know that I set it to -1 since it's not valid to start. We shouldn't need to change anything in the sync. Okay, so and the mount, the read shouldn't have to change either. Okay, I'm going to delete this for now since it's out of date. So let's compile, make sure it still works, or still compiles at least, and let's try running it. Now it should be slightly bigger. So it's 40, right? And that makes sense because we added 10 integers and each integer is 4 bytes. So that's 40 more bytes. So I think that data is there. It's hard to tell just looking at it, but let's assume it's working. Now let's go to the test file. So I've created it. So let's let's do a print and make sure the print works like that. And so we have all of our blocks. None of them are pointing to anything, and our inodes look right. Now, one thing to notice, the size of blocks is bigger than 512, and that's because each block also has a next block pointer. Okay. So next, let's comment out these parts and just do the mount and see what happens. See if it still works. And it and it doesn't, right? So it crashed. So it probably crashed because of how we're doing these read. It probably doesn't like okay. So it crashed because it didn't like, we're messing up on these. Let's change how we do this. I think this is probably more efficient anyways. Let's kind of try this. So I just want to say inode, give it that address, and then the size, and then here I'm going to say so. Let's try that, and let's do something similar for the disk blocks. Okay, let's try that. Oops. Okay, so it's when we're going to print our inodes. Oh, okay. I didn't allocate this space, so I'm just randomly writing that space. So I should do some mallocs. Oh, no, that wasn't it. Well, I think it's still a good idea to do the mallocs. Okay. Because these are arrays, I don't need to, this is just one element, so I need to use the address of operator. For these are arrays, and so I don't need to use the address of operator. Okay. And this is the blocks, right? This is the correct file system. Let's try changing our sync to use this style also. And I want to see if it turns out the same. So I'm going to copy my current version, and then we'll do a diff after to see if they're equivalent. And I need to change the test file. And compile. And now if I diff, they're okay. So they're exactly the same, they're identical. So what have we done so far? So we can read and write the super block. We're reading and writing the blocks in the data. We haven't actually created a file yet and set a file up. So that can be our next task. Okay. So let's go back to our system, and we want to allocate file, and let's pass it in a character string of at most 7 characters. Well, let's say 8, and we'll rely on them to include their null. And it'll return file number that they can work with. So what do we need to do to allocate a file? Well, first find an empty inode, claim it, claim a disk block, find and claim a disk block, and then return the file descriptor. So let's have those as internal ones. And let's just iterate through the whole super block. And return the first one. I thought about doing random things to make it more interesting, but I think we're too pressed on time. Okay, so we can see if the first block is empty or not. And if nothing works out, we're going to return -1. And we're going to want a similar thing for this block. Now for the this block right now we say -1 for the next block if it's not being used. We'll say -2 if it's the end. So -1 is empty, minus, yeah. So we have an empty block and an empty inode. And to claim it, we're just going to say inodes dot, well, we need to get our block first. And again, I really should be error checking. Okay, so that allocates a file. Let's test this out. So we've created our file system. Let's mount it. Let's allocate a file. I don't really care about the I don't really care. I'm not going to use the file descriptor yet. Now, if I do this, oops. Okay, probably typo. So let's see what our typos are. 85. Oh, okay. Let's just move these to the top. When the C compiler had gotten there, it didn't know about those internal functions yet. And yeah. Let's fix that. Okay. Now if we test it, okay, it shows up. Oh, it didn't fix. We didn't fix the name. So let's fix that also. Let's, okay. Okay, so we've allocated this. It points to this block, and then this block is marked as being used. Now, if I go and just mount it though, it's not going to show up. And what I didn't do was I didn't sync it. So let's allocate it and then sync it. Right. So it shows up, and now it's still there, right? And if I look at my data, I can see it here, and then yeah, I don't recognize the -1 versus -2, but okay. So what's next? Okay, so let's write some data to a disk block or to a file. Yeah. So let's, for our file, we're going to need to keep track of kind of where we are in it. So let's look at our interface. So we've allocated a file. It's probably not too interesting to read from the file yet. Let's set the size of the file. And then what we're going to do is we're going to copy data to the file. So we'll use position and some data, and we'll pass the data in just as a car star. Actually, just do write byte. Yeah. Okay. So let's implement these. Oops, I'm in the, oh, okay, yeah. Lost track of which file is in for a second. Okay, so we want to do these two. Setting the file size, we're going to adjust which block number, kind of the blocks that we have. And then writing a byte, we're going to go ahead and put it actually in there. Okay. So we're going to add and delete blocks as necessary. Let's go back and make a constant. So I'm not using magic numbers everywhere. Okay, so we need to know how many blocks so what we need to do here is just say size divided by disk block. What do they call it? Block size. Okay, and then I'm going to add 1 because I always have to. I need to round up essentially. Actually, if I want to be a little more particular, I could say something like if size actually let's do it this way. I think this would be more elegant. Sorry. So we can round up like this. Okay. So this will tell us how many blocks we should have. And now we're going to walk through and count them. So we got our first block, and so let's decrement our num, and then we're going to say while num is greater than 0, we need to make adjustments. So what do we need to do? So on each one we need to check the next block number. Okay. So int next num is equal to let me check, make sure that's the right name. Next block num. Okay. If so there's two cases, right? Either there is a next block or it's -2. So if it's -2, we're going to need to add more blocks. So if next num is equal to -2, then we need to find an empty block, and then we're going to set this current block equal to the empty one, and we're going to set the empty one to -2. Okay, and then we're going to say block number is equal to the next block number, and we're going to decrement how many we need to do. So this should grow. Okay, that should grow it. Now we need to check if we need to shrink it. So we're going to say while the block number, we really need to probably recursive would be easiest. So let's create something called shorten file and pass it in the current block number. And the way shorten file is going to work is we're going to look at the next block number if it's pointing to something, and say if it's greater than or equal to 0, then we're going to shorten the file again. And then here we'll set this to -1 to say it's not allocated. And down here, back in our set file size, we're going to set this one to be -2 to say it's the end. Okay. So that should walk through, and if we had a long file, it should make it shorter. And so now the file should be the correct size. Let's see if it compiles. It compiles. We didn't test that new function yet, so we're still at the same setup. Let's test the new file, test the new function. So we're going to mount the file system, and then let's set file size for file 0, and let's set it to be just 100, right? So it should only take one. That shouldn't have any effect. So that's our first case, no effect. Actually, let's do a couple, right? So we can set it to be 2 blocks, and then let's set it to a bunch of blocks, right? So like 9 or 10. and then let's set it back to one block. So this is 2 blocks, and you can see the chain here. So that looks good. This is, looks like 10 blocks, right? And you can see the chain. And then back to 2 blocks, or 1 block. Is that, yeah, 1 block. Okay. So set the block, setting the block looks about right. And for the last operation in this video, let's go ahead and write a byte. So let's write some data. Okay. So this is going to take the file num, the position, and the data we want to write. So the first thing we need to do is calculate which block, and then calculate the offset in the block, write the data. Okay. Well, actually we need to find the block number, calculate the offset in the block, and then write the data. Okay. So which block? Well, which block is going to be based on the position. So it's a relative block is going to equal the position divided by block size. And now we need to get that block. And so let's pass in the file num, and so we're going to make a new operation. So get block num. Actually, let's do this as yeah. So get block num. So how many blocks we need to go? We're going to set that to offset to start. And we're going to say while. And let's initialize it. Our block numbers. And we're going to say while to go is greater than 0. And then we're going to return the block number. So what we're going to do here is just walk down through it. So we're going to say this block number is equal to this block's, the current block number, and the next block number. So that should, then we'll return which block number. Okay. Now for the offset, that's just doing the mod operation. And so here what we're going to say is this blocks block number dot data offset is equal to data. So we're just going to assign that, and that should be it. Let's see if that compiles. Seems like it. Okay, so let's go with the big one, and let's do a little loop. And let's print out, let's put a character in like every 100 bytes. Okay, so we'll do this 49 times. And I called this function write byte. We're doing it on file 0. The address we want to use is I times 100, and then we're just going to pass in the character A. And yeah, let's try that. Okay. So, oops. So that should have terminated. I probably messed up my get block number. Right? I should subtract. So let's try that again. And let's look at the file system. And I can see I have the data spread out. Okay. So it looks like I'm able to write to the data, write to the file system. Let's go ahead and let's try again. Oops. Okay. So let's try again and see. Again, this isn't thorough testing, but okay. So we can see there's a first file and then our second file, right? And then the rest of the disk blocks and so on. So where are we at? You know, what? So we can write to the file. We didn't practice reading. I think that you should be able to see how that would come about. You know, we're mounting the file system, and so if I want to read data out, then that's a pretty straightforward operation. We have our super block. We have the inodes. We didn't do a bitmap for either of these. We just are iterating through them, which is slower, but again, trying to keep everything simple. And the blocks are chained, kind of like the file allocation tables. And you know, the operations, we need to be able to initialize the file system and then be able to write it out to disk. And then after we're writing it to disk, right, then we want to be able to read it. In practice, like real file systems, you know, instead of a file on, they're using a disk device. And then we can claim files. We didn't do delete files, but you know, you can think about that. Setting the file size, writing data, right? So some other operations you can think about would be delete and read byte would probably be the next ones to implement. But that's it for this video. Thank you and have a good day.